According to the Louisiana Electrical Code, specifically the 2020 National Electrical Code, GFCI, which stands for Ground Fault Circuit Interrupter, protection is required in several key areas of a home. These areas include kitchens, bathrooms, garages, outdoor areas, and crawl spaces. In kitchens, GFCI protection is mandated for countertop outlets and sink areas. This is because these locations are prone to water exposure, increasing the risk of electrical shock. Bathrooms require GFCI protection for all outlets, with a notable exception for shaver outlets. Again, the presence of water makes bathrooms a high-risk area for electrical hazards. Garages must have GFCI protection for all outlets. This is to safeguard against potential shocks from tools and equipment used in the garage, especially when working with water or on damp surfaces. Outdoor areas also necessitate GFCI protection for all outlets. Exposure to weather elements increases the risk of ground faults, making GFCI protection crucial. Crawl spaces require GFCI protection for all outlets as well. These spaces are often damp and may contain exposed wiring, increasing the risk of electrical hazards. It is important to note that while GFCI circuits can share with other outlets, there are specific considerations to keep in mind. Firstly, ensure that the total load in the circuit does not exceed its ampacity, which is usually either 15 or 20 amps. Overloading a circuit can lead to overheating and potentially cause a fire. Secondly, the first outlet on a shared circuit must be a GFCI outlet. This ensures that the entire circuit is protected from ground faults. Ground fault circuit interrupters, or GFCIs, are essential safety devices designed to prevent electrical shocks and fires. They operate by detecting ground faults, which occur when unwanted current flows to the ground. When a ground fault is detected, the GFCI trips the circuit breaker, cutting power to the outlet and preventing electrical shock. This rapid response is crucial in protecting people from potentially fatal electrical injuries. Ground faults can occur for various reasons, such as damaged appliance cords, water intrusion, or faulty wiring. Without GFCI protection, these ground faults can lead to dangerous electrical shocks, especially in areas where water is present. In addition to preventing shocks, GFCI outlets also help prevent electrical fires. Ground faults can cause arcing, which generates heat and can ignite flammable materials nearby. By quickly interrupting the circuit, GFCIs prevent arcing and reduce the risk of fire. If a home does not have GFCI outlets in the required areas, it may not be up to code. It is crucial to address this issue to ensure the safety of the occupants. The first step is to bring the issue to the attention of the builder and electrician immediately. Request that they install ground fault circuit interrupters in all required areas according to the Louisiana Electrical Code. If the builder and electrician are unwilling to comply, it may be necessary to contact the local building department and file a complaint. Building departments are responsible for enforcing electrical codes and ensuring that homes are built to meet safety standards. To elaborate on ampacity and circuit load, ampacity refers to the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. It's a crucial factor in electrical safety, as exceeding the ampacity can lead to overheating, insulation damage, and even fires. The National Electrical Code, or NEC, provides tables that specify the ampacity of different types of conductors based on their size, material, and insulation type. For example, a common 14-gauge copper wire with type THHN insulation might have an ampacity of 15 amps, while a 12-gauge wire of the same type could have an ampacity of 20 amps. When designing or modifying electrical circuits, it's essential to select conductors with an ampacity that is sufficient for the intended load. The load refers to the total amount of current drawn by all the devices and appliances connected to the circuit. To determine the load, add up the current requirements in amps of each device. This information is typically found on the device's nameplate or in its user manual. It is good to remember that it is a common practice to direct circuit breakers to 80% of their rating for continuous loads. This means that for a 20 amp circuit breaker, the continuous load should not exceed 16 amps. This dirting helps to prevent nuisance tripping and ensures the longevity of the circuit breaker. Regarding the NEC, it is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and updated every 3 years by the National Fire Protection Association, or NFPA. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is widely adopted by state and local jurisdictions, and compliance with the NEC is often required by law. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. For example, Article 210 covers branch circuits, Article 250 covers grounding and bonding, and Article 300 covers wiring methods. The NEC also includes numerous tables and examples to aid in understanding and applying the requirements. Staying up to date with the latest edition of the NEC is essential for electrical contractors, inspectors, and anyone involved in electrical work. Changes and revisions are made with each new edition to reflect advancements in technology and address emerging safety concerns. GFCI outlets are an important component of electrical safety, and the NEC specifies where they are required to be installed. It is good to understand the requirements and ensure that your home or building is in compliance. Regarding Louisiana's specific electrical codes, it is imperative to be aware of and adhere to any state-specific amendments or additions to the National Electrical Code. States often adopt the NEC with modifications to address local conditions and priorities. It is worth verifying with the Louisiana State Fire Marshal or the local building department to ensure compliance with the most current and applicable electrical codes. This may involve additional requirements or clarifications beyond what is found in the NEC itself. One additional safety measure to consider is arc fault circuit interrupters, or SIs. SIs are similar to GFCIs but are designed to protect against arc faults, which are another common cause of electrical fires. Arc faults occur when there is an unintentional electrical discharge between two or more conductors. SIs detect these arc faults and quickly interrupt the circuit, preventing a fire. While SIs are not required in all locations, they are often recommended for bedroom circuits and other areas where there is a high risk of fire. Consider consulting with a qualified electrician to determine if SIs are appropriate for your home or building. They can assess your specific needs and make recommendations based on the latest electrical codes and best practices. When selecting GFCI outlets, it is important to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. UL listing indicates that the product has been tested and meets established safety standards. Look for the UL mark on the product packaging or on the device itself. Also, choose GFCI outlets that are tamper-resistant, especially if you have young children in the home. Tamper-resistant outlets have internal shutters that prevent children from inserting objects into the slots. When installing GFCI outlets, be sure to follow the manufacturer's instructions carefully. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the job. Improper installation of GFCI outlets can create a safety hazard. Regularly test GFCI outlets to ensure that they are functioning properly. Most GFCI outlets have a test button that you can press to simulate a ground fault. When you press the test button, the outlet should trip and cut power to the circuit. If the outlet does not trip, it may be defective and should be replaced. Test GFCI outlets at least once a month to ensure that they are providing continuous protection. When sharing GFCI circuits, it is also important to consider voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause appliances to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and recommends limiting it to a maximum of 3% for branch circuits and 5% for feeders. To minimize voltage drop, use conductors with a larger gauge and keep circuit lengths as short as possible. In addition to GFCI outlets, there are also GFCI circuit breakers available. GFCI circuit breakers provide the same level of protection as GFCI outlets but protect the entire circuit rather than just a single outlet. GFCI circuit breakers are often used to protect circuits that serve multiple outlets or appliances. They are also a good option for protecting circuits that are difficult to access, such as those located in crawl spaces or attics. When selecting GFCI circuit breakers, choose products that are compatible with your electrical panel. Be sure to follow the manufacturer's instructions carefully when installing GFCI circuit breakers. Again, if you are not comfortable working with electricity, it is best to hire a qualified electrician to do the job. Another important aspect of electrical safety is grounding. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and de-energize the circuit. Proper grounding is essential for preventing electrical shocks and fires. The NEC specifies the requirements for grounding electrical systems and equipment. It is important to follow these requirements carefully to ensure that your electrical system is properly grounded. Grounding electrodes, such as ground rods and metal water pipes, are used to connect the electrical system to the earth. The size and type of grounding electrode required depends on the size of the electrical system and the type of soil. Grounding conductors are used to connect electrical equipment to the grounding electrode. The size of the grounding conductor required depends on the size of the circuit. It is also important to bond metal enclosures and equipment to the grounding system. Bonding creates a low impedance path for fault current to flow back to the source. Bonding conductors are used to connect metal enclosures and equipment to the grounding system. The size of the bonding conductor required depends on the size of the circuit. Regularly inspect your electrical system for any signs of damage or deterioration. Look for cracked or broken outlets, frayed wires, and loose connections. If you find any problems, have them repaired by a qualified electrician as soon as possible. Do not attempt to repair electrical problems yourself unless you are a qualified electrician. Electricity can be dangerous, and improper repairs can create a safety hazard. When working with electricity, always follow these safety precautions. Firstly, turn off the power at the circuit breaker before working on any electrical circuit or equipment. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear rubber gloves and safety glasses to protect yourself from electrical hazards. Fourthly, never work on electrical circuits or equipment when you are wet or standing in water. Fifthly, always test the circuit to make sure it is de-energized before working on it. A non-contact voltage tester can be used to test for voltage without touching the wires. In summary, GFCI outlets are essential safety devices that protect against electrical shocks and fires. They are required in kitchens, bathrooms, garages, outdoor areas, and crawl spaces. Ensure that your home or building is up to code by having GFCI outlets installed in all required areas. Regularly test GFCI outlets to ensure that they're functioning properly. Follow all safety precautions when working with electricity.